let's start with 13, and then if you guys want to add anything else, we can. And again, so the way you set up your scale on your graph is going to make a difference on how your graph looks, but at the same time, it doesn't mean there's only one right answer for that. So when we're doing this, remember it's a times the cosine of bx, basically, is what we're looking at here, where a is our amplitude. So our amplitude is 4. That's how high and low it'll go. And then the period comes from 2 pi divided by b. So in this case, that's 2 pi divided by 3/4. Now, I can't divide fractions unless I just use my calculator. I have to multiply by the reciprocal. So this really becomes 2 pi over, or times 4 over 3. So the period actually becomes 8 pi over 3, which is a very strange period, but that's how long it takes for it to fully repeat. So what I did on my graph, the thirds made me think, let's count 3s, like so, but at the same time, that doesn't really help all that much, just because 8/3 is kind of an icky number as it is. So I made this, like, I counted 1, 2, 3 and made this 8/3, but it doesn't really matter where you went with it. So I don't know if anyone has a preference on what they wanted to see it as. Because I guess now thinking about it, if I went 2 pi over 3, 4 pi over 3, 6 pi over, you know, I kind of did it that way. So if I call this 4 pi over 3, then this would be 8 pi over 3. I don't know if that's better, worse, whatever. But the biggest thing with this is our amplitude is 4. So that means I need to start up at 4. And if you didn't try this already, with cosine, we know that the cosine, typically the pattern is this. So it goes 1, 0, negative 1, 0, 1. If my amplitude is 4, that's going to change this to look like this instead. So what that means is I'm going to start up at 4. So at 0, I'm going to put a dot at 4. And then I'm going to end at 4. So what I'm going to do is at the end of the period, 8 pi over 3, I'm going to put another dot at 4. So it starts and ends in the same spot. In the middle of those two is going to be negative 4. So between those two is 4 pi over 3. I'm going to put in a dot at negative 4. And then between that, like those halves, there's going to be zeros. And then you try to hit the dots better than I do. And you can repeat it. So you get it a couple times. Great. Any other ones you guys want to see? Because today we're adding to this where we're going to take now the sine and cosine and actually move them left, right, up, and down. So we're not just sticking with this. So any others that we need to see? So this whole chapter of graphing, sine and cosine are the basic of all this, and so and I know this takes some time to get used to. It's different than regular graphing, so just feel free to stop me and let me know if we need to redo something or explain it again. All right, let me get you guys our notes then for today. And again, they look really long because they are long. No, just because the graphs are big. And this one I wanted to show you guys a little bit more, maybe more examples of each one. So you can kind of see different situations.
Yes, ma'am.
That's it. Yeah, we can. I think they're well, I don't want to be March Is there a trade? You would have been there. How was that? Did you get a picture? For basketball. Yeah. I didn't see you. Okay, as soon as you start calling this movie automatically and what will it do?
Okay, so the warm-up question, guys, is asking you to graph 3 times the sine of 2x. So again, similar to what we were doing yesterday. So thinking about what the A is and the B is. Amplitude, what's the amplitude in this case? Yeah, 3. So that means it goes up to 3, down to 3, or down to -3, sorry. So again, when I think about sine, it might be helpful to try this where it starts at 0, goes to 1, 0, -1, and then 0 again. And if I multiply that by 3, that's going to just change like 2 of those values. But it'll go up to 3, down to -3. The B value in this case is 2. So what does that make our period? It's just going to be pi, because you do 2 pi divided by 2. So pi is going to make sense for our period. And again, that's why we want to simplify that in terms of a fraction. 2 pi over 2 is just pi, so we want to write that. When I go to put this on my graph, it's up to you guys how you guys want to set this up. It doesn't really matter to me, like in terms of like how far you go. I typically try to have the period either like being like an even number of spaces away, like 2 or 4. So to me, going over here to pi, is that what you guys did? Or did you make that 2 pi? That pi? Okay, and then that makes this 2 pi. That gives me, I get 2 periods in during that time. When they're too squished together, they're just really hard for, I think, to draw and to kind of figure out what's going on. So I like putting them further apart if possible, but not too far that I have to draw it all over the place. But so it starts at 0, and it's going to end at 0. And in the middle, it's at 0 again. So again, that's why I like an even number, because it's kind of broken into fourths here. But sine starts at 0 and then goes up to 3, and then down to -3. And again, trying to draw that as a curve as best we can. It shouldn't look like you took a ruler and drew, you know, like the... And then we can repeat that another time. Okay? So what we're going to do today with this is we're going to take that graph and then we're going to move it left, right, up, and down depending on some different things we're going to change about the equation. Now, just so you know, if you ever, like, if you Googled this or something or looked up like some practice problems like this, You can either do it in radians or degrees. We're going to stick with just radians, although that sounds worse. Actually, I think it makes it a little bit easier just because that's what we've already been graphing in. So I'm going to move it like pi, you know, to the left or something, and that means we'll move it down. So we'll talk about these equations. So hopefully the first part of this equation looks familiar to you. So the A and B, we've already talked about, that A is the amplitude and B helps us with the period. So if it's important, like if you think you want to have that written again, because we're obviously going to be using that again, so remembering that A is our amplitude, and then the period comes from 2 pi divided by B. So that has not changed. So that's still like in like effect here. So if you need to remind yourself of that, that's important. So what we're going to do today is, again, horizontal translation. So that means basically left or right. They also can call that a phase shift. It's kind of a fancy way to say that you're moving left and right. Why do they use that? I don't know. So horizontal is left and right. Now, actually, I think I want to point something out to you guys, and then vertical will be obviously up and down. So if you guys have like cell phones or computers, whatever you guys want to get out, we're going to get out Desmos. So those of you guys who hate Desmos.
50 bonus stars with Starbucks. I have to order 2 days in a row.
So Desmos is D-E-S-M-O-S. If you never used that before, it's an online graphing calculator. It's free.
Whoopsie doodles.
Yeah, if you've never used it, I mean, it's kind of, there's an app, but there's also a website. So Desmos, if it goes into something like a kind of a home screen, then just click like start graphing. You just want to go into the graph. And so when you guys go to graph, we're going to type in, we're going to do sine of x first, because I want to talk about just the basic graph. So y equals sine of x, we're going to type in the first function bar. And again, some of you guys have used this before, others of you haven't. There are actually functions where you can like use sine. So we have our sine of x. Now I want you to leave that one there so that you can compare it to one that we're gonna like graph similar to that. So what the nice thing about Desmos is it's colored, so it'll change colors for us for the next one we want to graph. So I'm gonna do y equals, and we're gonna add or subtract something to that x. So right now sine of x is the same, but let's like subtract 1. So I subtracted 1 from the sine of x, or sine of x minus 1. All right, so yeah, that's what we want to figure out. So when I took minus 1, it went from red to blue. So we want to explain like what's happening there, or maybe make a prediction about what's happening in terms of our graph. And it's kind of nice, your graph like does show you some nice like little coordinate points here. It kind of gives you some information. Like kind of sometimes those points are going to be helpful for you. Anyone want to tell me what subtracting 1 or doing x minus 1 did to my graph?
To the right.
Yeah, go ahead. Yeah. It moved to the right one. So what do you think, I don't know, adding 4 would do?
Move it right.
So let's,
Oh, sorry, left.
okay, yeah, let's look. And this one might be a tougher one to see here because of, I might not want to do 4, I might want to do 3. Because 4, I think, will take it right back to where we were. Oh no, 4 is okay. Oh, look at that. That almost looks like DNA or something, right? I don't know, right? Is that, or what is that? The helix like thing? Like,
Yeah,
right?
DNA.
Yeah, okay. Like she laughed at me, so I was like, maybe I'm not very good. My DNA looks that lovely. All right. Well, this is prettier, so that's all that matters. All right. My DNA. All right. So, what I want you to see with that is how adding or subtracting a value inside of the parentheses changed my graph. And so when we did -1, it actually moved, you guys said, to the right one. But then when we added 4, I guess we didn't really say that, we got distracted by DNA. When we added 4, I think it actually moved then to the left 4, right? Because it's at -4. So kind of, I guess, interesting in a way, but also there's a rule there. So now this is a little bit confusing because of the fact that the C value here is x minus C, so that looks a little confusing. So if I might just give like a quick little example here. So if C is technically positive, so if I have sine of x minus C, C is technically positive in that case because you're subtracting it in the formula. We're going to move to the right C units. So it's kind of confusing there. It's kind of an opposite sign. And those of you guys who are doing pre-calc right now or did pre-calc already, this is kind of like your H and K, where it does kind of the opposite of what you expect in like ellipses and all the different circles and stuff we did. So it kind of does the opposite of what we're expecting. So it's important to notice there's that opposite sign there, that negative that changes that. So then if I add a number, it looks like I'm adding, it's actually then going to move to the left that number of units. Now why this is going to look so tough today is because when we're moving left and right, what is our scale on the x-axis? What kind of scale do we have? Like look at our warm-up question. Like what kind of numbers do we have on our x-axis? We have like pi. So the reason why this is going to look so weird or look hard on our homework is because I'm going to tell you to move it left or right pi units. Like that looks really awful, or pi over 2 or something like that. But if that's our scale, that doesn't really make it that much harder. So just be careful about that as that goes. Okay? The next one I want you guys to look at is what if the number's outside the parentheses? So we're going to change this up a little bit. So if you still have your decimals handy, if you don't, it's okay. But this time, rather than inside the parentheses, we're going to put it outside. So we're going to close the parentheses first. Whoops, I need an X in there on mine. And then I'm going to like add 4 then after that. So feel free to play around with this a little bit, kind of see like, so I added 4 outside the parentheses. So that slight difference inside parentheses versus outside makes a big difference. Like obviously that did a lot different, you know, movement to our